This is LT1C Notes Part 2, Domain and Range. So before we start talking about domain and range, let's get the idea of a set out of the way. And a set is a collection of things. It can be any collection of things, but with math, that really means numbers. And something that you're used to is the number line. All the number line really is a collection of numbers. It's a visual representation, right? We have 0, we have a 1, we have 1.5, and so on. Now, for domain and range then, what we are interested in is if I give you the graph, are you able to tell me what the domain is? And the domain is simply all the inputs or the x values that are on the graph. Likewise, for range, we want to know the set of all outputs or y values that are on the graph. Now, what do I mean when I say it's on the graph? Well, consider the graph below, and the question is x equals to 2 on the graph? What about x equals 5? Well, here is x equals to 2, and if I draw a line going up and down, we say that x equals to 2 is on the graph if this line touches the graph anywhere. And we can see that clearly it touches the graph at 2, 0. So because of that, x equals to 2 is on the graph. What about x equals 5? Well, we have 1, 2, 3, 4, 5. Here's my value, x equals to 5. Let me draw a line that goes up and down. And the reason why we're drawing this line is because this line represents every single point in the world with an x value of 5. Now, does this line touch the graph? Well, no. Right? We can see that they do not intersect at all. So because of that, we say that x equals to 2 is in the domain, but x equals to 5 is not in the domain. And so when we move on to stating the domain, what we want to do is we want to find all the x values that touch the graph somewhere. Now moving on to our y values, is y equals to 1 on the graph. What about y equals -6? Well, here's the point y equals 1 on the y-axis. And so in highlight, here are all the points with y values of 1. And does it touch the graph somewhere? And we can see that it does. Now, is it a problem that it touches the graph twice? For the purposes of domain and range, it doesn't. All that matters is that it touches the graph at least once somewhere. So for y equals 1, the answer is yes. And so what about y equals -6? Well, here's y equals -6. And here's all the y values of -6. And we can see in this case, this line will not touch the graph. Whoops. And so y equals -6 is not on the graph anywhere. And so because of that, we can say that y equals 1 is in the range because it's on the graph, whereas y equals -6 is not in the range because it is not on the graph. Okay, let's go ahead and move on. So with that said, we can now use our interval notation to start describing domain and range. We're not going to really be working with set builder notation. So the way I like to do this is for domain, because we are interested in finding the x values, imagine taking your pencil and holding it straight up and down like so. And then starting from the left and making your way right, because we want to go from least to biggest. If you sweep your pencil from left to right, what is the first thing that we hit? Well, the first thing that we hit is this arrow that goes to the left. I know it's a little misleading because it looks like the arrow only goes to the up direction, but all arrows have a left/right and an up/down. So because this arrow does go to the left forever, we say that the domain starts at -infinity. And then if you continue sweeping your pencil to the right, we will then hit another arrow. And since this one goes to the right, our domain goes to +infinity. Now for range, what you want to do is you want to make your pencil move left and right, because this is how we check for the y values. And then the way that we do this is we go from bottom to top, because again, we want to go from least to biggest. And so if you move your pencil up and down, the question becomes, where is the first place do you touch the graph? And the answer to that is going to be this value right here. It's y equals 1, 2, 3, 4. And so we will throw a 4 here. And because this point is considered filled in, we do want to include it in the range. And then if we continue sweeping our pencil, we'll hit the arrows that are pointing upwards. And so the range will go up to +infinity. So that's exercise A. Moving on to exercise B. Sweeping our pencil left to right for domain, we see that the first point that the graph is going to hit is going to be at -3. But in this case, because there is an open circle at -3, we use a parentheses. And then if you continue sweeping your pencil to the right, your pencil will still touch the graph, and it'll stop touching the graph at 1. And because this is a closed circle, we want to include the x value of 1. Whoops, that should be underneath the interval notation. Now for range, again, you want to go from bottom to top, and so the first y value that our pencil touches will be at -4, and because it is solid and filled in, we include the -4. And then if you move your pencil, dragging it upwards, we'll stop touching the graph at 0. Now the question here is, notice that our line touches the graph in 2 places. In one place it's an open circle, and in one place it's a closed circle. So which symbol are we going to use? Well, remember that to be in the range, it just has to touch the graph somewhere that is filled in. As long as it happens in at least one place, it's considered to be a part of the domain/range. And so for this problem, because it touches the graph here and it's filled in, we do include the point in the range. Okay, moving on to part C and D, we'll go through these a little quicker. For domain, first place that a line will touch the graph when we go from left to right will be at -1, 2, 3, 4, 5. And because it's an open circle, we use parentheses. And then continuing to sweep, I realize that should have been in blue, sorry, or green. And then continuing to sweep, we'll stop touching the graph at 1, 2, 3, 4, 5, 6. And because the graph will touch open circles there, we use parentheses for both. Now moving on to our range. Starting at the bottom, the first time that our line touches the graph will be at 1. And because they're both open circles, it doesn't actually touch in any place that's filled in, so we use a 1. And then continuing to sweep up, it might look tempting to stop at 3, but notice that if you sweep your pencil upwards, you're still touching graph. And you don't stop touching the graph anywhere until you get to this point that I just filled in. And so that has the y value of 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the range stops at 9. And because it's filled in, we use a bracket. Again, I realize that that answer should actually be down there. Okay, part D actually isn't too interesting, so we'll go ahead and skip that. And let's go ahead and jump to more complicated problems. So I don't forget, I'm just going to cross out the set builder portions. So these are a little bit more complicated, but they're not too bad. So for part E, we have domain. Again, if you take your pencil up and down, and you move it to the left, the first time that it touches the graph is an arrow that goes down and to the left. Now again, it might be tempting to write in this case, it will be a negative infinity because the arrow goes to the left forever. And something interesting is going to happen. If I continue to sweep to the right, the last line that I just drew, what happens here? Because there is a gap, or what looks to be a gap, it might be tempting to close off our domain. But what actually ends up happening is because I am still touching the graph somewhere, the domain actually doesn't have any openings. It actually just keeps on going forever until we hit to the right arrow. So in this case, the domain goes from negative infinity to positive infinity. It's a little bit hard to see because I have no way to show you, but if you use your pencil and sweep from left to right, you can ask yourself, am I touching the graph? Am I touching the graph? Am I touching the graph? And because we're able to go from the left arrow to the right arrow, and we're always touching the graph somewhere, for the purposes of domain, there is no gap. Now, the range part is going to be a little different. If I take my pencil, left and right, the first thing that I hit is a down arrow. So that's going to be negative infinity. And if we continue to sweep upwards, notice that I touch this circle here. And then from here, there is a gap, right? It's literally impossible. If you take your pencil and go left to right, where the brown highlight is, you aren't touching the graph anywhere. So for the purposes of range, there actually is a legit gap. So what has to happen is that we need to close off our interval at the y value of 0, use a parentheses because it's not filled in, use a union symbol to denote that there's a gap, and then we're going to link it to the y value of 1, and then because it is a closed circle, we do include that y value, and then from there, continuing on, we do hit a up arrow, so we'll use positive infinity, and then use a parentheses. Okay, let's go ahead and do part F. So for domain, notice that the first thing we hit is a left arrow. So we have negative infinity. And then as we continue to sweep our way towards the right, Again, notice there's this weird case where it looks like there's a gap, but for the purposes of domain, as we go from left to right, we actually are always touching the graph. And then that will continue until we hit the right arrow. For range, notice that the bottom of the graph is this flat line. And so we kind of discussed this in the previous section. We have a singleton value, and so the graph starts at 2. We're going to include it, and then it ends at 2. And then we have this gap that I'm going to denote in brown. And then the graph continues again. And it continues at 1, 2, 3, 4, 5. Because it is a unfilled circle, we'll use a parentheses, and then continuing onwards, we'll hit this arrow that goes up, and so this goes till positive infinity, and don't forget the union symbol because we do have a gap for this problem. We'll do one more for part G. In this case, there is not an arrow for this problem, so the graph starts at -5 for the domain. It's filled in there, so we use a bracket, and continuing to sweep. Notice that there is going to be a gap for the domain for this problem. So when do I first have to lift my pencil? Well, that's going to happen at the x value of 1. And because it's a filled-in circle, we use a bracket. And then where does the graph start off again? It starts off at 2. And then it's an unfilled circle, so it's a parentheses. And then we continue in this manner until we hit this x value of 5. And then don't forget the union symbol. So there's our domain. Correction, that is a bracket on the 5. And lastly, we have our range. So taking our pencil, we notice it first touches the graph at the y value of -2. And then as we move our highlighter upwards, take a look at that last highlight line I just did. Again, in this case, it might look like there's a gap, but the question is my pen still touching the graph somewhere? And the answer is yes. And it keeps on touching the graph, and it keeps on touching the graph until it gets to that top horizontal line. So in this case, even though it looks like there's a gap, the gap is only relevant for the domain part. It's not relevant for the range part. So the graph goes up to 4, and then we close it off there. So to summarize, in this section, we talked about domain and range. In particular, make sure that you're careful about parentheses versus brackets. And the hardest part really is these last 3 problems where we have to deal with gaps and understanding why, even though when it looks like there's a gap, sometimes it's one continuous section, and sometimes we do actually need to break it up. And the trick that I use is to take your pencil and sweep along the graph. If your pencil stops touching the graph completely, then we have a gap. If your pencil is able to go from left to right, and it's always touching the graph somewhere in the world, then it's one continuous section.